Hello, everybody. Welcome to another episode from the RPA Vanguard channel. My name is Andy Menon. In this video, we are going to be taking a closer look at UiPath State Machines. Let's get started. Before I begin, I would like to make it clear that this is not a beginner's course on state machines. I would highly recommend that you familiarize yourself with the fundamentals of state machines, and there are a couple of ways to do it. The first and the recommended way is to take this course on state machines from the UiPath Academy site. This is a great course, and as you can see, it's one of my favorites, and it will teach you the concepts of state machines. And the advantage of going through this course is that if you are a beginner and you are getting into the robotic enterprise framework that is based on state machines, it will make it that much easier for you to learn the RE framework or the robotic enterprise framework. And therefore, I would take this as the recommended path to familiarize oneself with the basics of state machines. The other is more of a quick start, and that approach would take you to this documentation page on state machines. And this documentation page will get you started quickly by showing you how to construct a guessing game based on state machines, right? So regardless of the approach you take, by the time you get into this video, you must be familiar with state machines in one way or the other. So what I have here is a template or a project that's based on the template of a robotic enterprise framework, right? And if we open up any of these states, right, the init state, the get transaction data or process transaction, you will see one thing in common. You will see that the entry state or the entry part of this state has been populated, and there's a lot of logic going into it. But most often than not, you will see the exit is not populated. There's nothing in the exit part of this state. Similarly, if you go into the get transaction state, here again, you will see that the entry part of it is very exhaustive. And when you get into the exit part, there's nothing here. And similarly, if we get into the process transaction, you will see that the exit is empty, right? So when I was learning state machines, I was already thinking about why this is empty and how would I use it, right? So in this video, we are going to be taking a look at how to use the exit attribute of the state activity in state machines, right? And for that, what I have done is to make the learning process easier. I've taken this example of this guessing game and I have enhanced it, right? I have made it a bit more fun. And I'm going to step through the demo in a bit. And hopefully by the end of this video, you will at least have some idea on how to use the exit attribute of a state in UiPath State Machines, right? So with that, let's get into the demo first, and then we can come back to see how that game has been enhanced. All right, so I have opened up this example project in UiPath Studio, and you can see that this is the guessing game. And if you're already familiar with the guessing game example, you will see that there's nothing fantastic on the surface of this project, right? I mean, you have the initialize, you have the guessing stage, and you have the final stage. And if you compare that to the example, you will see that there are very little differences, and you have only 3 states, right? But the similarity ends there, right? And there's a little bit of difference under the hood when it comes to this enhanced guessing game, right? So with that, what I'll do is I'll just run this project and we'll go through one round of this guessing game, and then we'll come back and see what the enhancements are. So as you can see, there is a slight difference between the normal guessing game and the guessing game you're looking at here. What this iteration of the guessing game does is it keeps track of the number of guesses that you went through to guess the right number, and based on the number of guesses, it gives you a classification, right? And the fun part is that there are different levels. If you have guessed the number within 3 chances or 3 turns, then you are at the top of the game, right? You are a machine whisperer. You basically can understand what the machine is thinking, right? And if you are between 4 and 7, that probably makes you a normally skilled player, right? And if you're greater than 8, then you're probably rusty, right? So you can see that this game is a bit more interactive than the normal guessing game example you have seen, right? So let's go back to the project and take a look at the enhancements. So coming back to the project, you can see that there are many number of log lines written out here. And one of the things that you will see is that the machine writes out each time you take a guess, the machine sort of writes the count of the guess. So here I guess the number within 5 guesses, and then by the time you reach the end and you guess the correct number, it writes out this line, right? It says, yeah, awesome, it's a great guess, right? So how did we do that, right? The first thing we'll do is get into the initial state. Now, there's nothing different about the entry point of the initialized state, right? The machine will guess a number, and then what is different here is the exit, right? Unlike the other examples of state machines you're familiar with, you will see that the exit has been populated with something, right? At the most basic level, you can use the exit point of a state to log something, right? In this case, I'm just logging a friendly message, and I'm saying that the game is ready to be played, and the machine has already guessed a random number, right? So at the basic level, I have used the exit point of this initial state to write that message out, right? Now comes the second state. So in the second state, the player guesses a number, and if that number is too low or too high, there is a loop that goes through and brings you back to the same state until you have guessed the right number, and then the state transitions to the final state, right? Getting into the player state, again, there's nothing much different about the entry part. Here, the machine will present a dialog box to you to guess the game, guess the number, as long as you have not guessed the correct number, right? And in the exit, what it does is it performs the logic to track the number of guesses, right? So here we have guess count, which is a global variable. And what it does is each time you guess a number, you input your guess, it counts the guess count by now, it increments the guess count by 1, right? And then it logs the guess count to the output, right? And you can see that the exit is not always useless. You can always use exit to prepare or to perform additional logic to enhance the functionality of your state machine, right? So here, it keeps track of the number of guesses that you have gone through to arrive at the right number that was guessed by the machine, right? So the question comes, where are you going to use this guess count, right? So the guess count will be used in the end or the final state of the state machine, right? Now imagine you have guessed the right number, and in this case, as you saw in the demo, I guessed this number within 5 iterations, right? And now if I get into the final state, as we know, the final state doesn't have an exit, it has only an entry point. What the logic here does is it takes the guess count that was recorded in the exit of the player state, and then uses that to classify the player, right? Classify your level, right? And the logic is pretty simple. And here is a flow, is a logic written in the form of a flow. And if I bring this into focus a little bit. So here, what it does is it takes the guess count, and if your guess count is less than or equal to 3, then you are at the top. You are at the top level, right? You are a machine whisperer. You basically, within 3 guesses, you can figure out what the machine is thinking, right? And if not, if your level is somewhere between 4 and 7, if your guess count is between 4 and 7, then you are you're a regular player. You basically have some practice of of having to guess what your machine is thinking. And if your guess count is greater than or equal to 8, then you're really a rusty player, right? You have absolutely no practice, and then you'll have to practice a little bit to come up to at least the normal level, right? If not, you have no hope, right? Basically, this is terrible, because if you're taking like 50 guesses to guess the number, then basically you're just mechanically putting in a number or your guesses, but really not strategizing how to arrive at the right number. So there's no end to how much you can enhance this, right? You could probably log the player and the status to some database, and you can restore that when the game starts up next. You can recognize the player and load their last status, and probably put a message saying, hey, last time you were a normal player, why don't you try to shoot to a machine whisperer status, which is the top level, right? This is what I wanted to cover when it comes to state machines, because I did not see many examples where the exit points of the state were used. And I hope you find this video useful and use it to enhance your state machines. So if you like this video, please do like and subscribe to my channel. I'll truly appreciate it. Thank you, and I'll talk to you soon. Bye.